Hello, welcome to NeoScribe. As far back as the 2nd millennium BC, ancient astronomers identified 5 celestial objects moving differently than the backdrop of stars. The Greeks called them planetes, meaning wanderers, and many ancient civilizations would go on to worship them as deities. With its abundant iron oxide dispersed on its surface, giving it a reddish appearance, the Romans worshipped Mars as the god of war. Over time, mystical worship shifted to fantastical speculation of intelligent life on Mars. In 1877, Italian astronomer Giovanni Schiaparelli observed a network of linear structures on the surface of Mars, leading to a surge of speculation of the possibility of intelligent life on the planet. The idea of an advanced Martian civilization was widely covered by newspapers and magazines, along with many science fiction novels, capturing the imagination of the public, right up to the space age and the first missions to Mars. Between October 1960 and November 1962, the Soviet Union launched 5 missions to Mars. Each one failed. NASA continued that streak of misfortune in 1964 with the failure of Mariner 3. 3 weeks later, NASA launched the Mariner 4 spacecraft, becoming the first successful mission to Mars. Mariner 4 was a flyby mission, and it reached Mars on July 14, 1965, marking an incredible historic moment. Equipped with a telescope, Mariner 4 took 22 close-up images of Mars. These were the first images ever captured and returned to Earth from deep space. Mariner 4 transmitted measurements of Mars' atmosphere, which turned out to be much thinner than expected. Additionally, it did not detect a magnetic field, radiation belts, or surface water. These findings dashed the hopes of discovering intelligent life on Mars. Just 2 days after Mariner 4 was launched, the Soviet Union launched the Zond 2 spacecraft, but they lost communications with it, making it the 6th failed Mars mission in a row for the country. Then NASA went back to Mars with Mariner 6 and 7, launched in February and March 1969. 6 and 7 were both flyby missions, and both were successful. The spacecrafts uncovered that Mars' atmosphere is comprised of mostly carbon dioxide. They also were able to transmit 201 images back to Earth, covering around 20% of the surface. But the images did not reveal any of the canals mistakenly observed by late 19th century astronomers, another letdown for intelligent life hopefuls. However, Mariner 6 and 7 detected trace amounts of water on the surface of Mars, providing some hope to finding life on the planet. Back to the Soviet Union, it launched the Mars 2M number 522 in 1969 and the Kosmos 419 in 1971. Both missions failed, extending their streak to 9 unsuccessful missions. And then finally, in May 1971, the Soviet Union launched the twin space probes Mars 2 and 3. The probes were identical, each consisting of an orbiter and a lander. Both orbiters were successful, transmitting a total of 60 images, discovering mountains as high as 22 kilometers, and revealing surface temperatures between -110 and 13 degrees Celsius. And the orbiters likely remain in Mars orbit to this day. Mars 2 and 3 landers, on the other hand, did not fare so well. Meanwhile, back at NASA, they launched 2 orbiters, Mariner 8 and 9, also in May 1971. Mariner 8 failed, but Mariner 9 was highly successful. Despite launching 11 days after the Soviets' Mars 2 and 3, Mariner 9 beat the others to Mars, becoming the first spacecraft to orbit another planet. When Mariner 9 arrived at Mars, it found the surface completely covered by a planet-wide dust storm, and scientists had to delay imaging for months until the storm settled. Mariner 9 was able to transmit over 7,000 images, covering 85% of the planet's surface. The images revealed riverbeds, vast canyon systems over 4,000 kilometers long, along with massive extinct volcanoes, including Olympus Mons, the largest known volcano in the solar system. 1973 was a busy year for the Soviet Union, which launched Mars 4, 5, 6, and 7. All 4 missions failed for the most part, except Mars 5 managed to transmit 180 images before it was disabled, likely from a micrometeoroid. At this point, the Soviet Union only had 2 successful missions out of 18, and it wouldn't attempt another mission on Mars for 15 years. Moving on to 1975, we have NASA's Viking 1 and 2. The Vikings were pretty much identical, both consisting of an orbiter and a lander, and they were a smashing success. The primary mission for the Viking 1 orbiter was to take global images of Mars days leading up to the orbit. This amazing mosaic image of Mars was made possible by the work of the Viking 1 orbiter. Viking 2's orbiter transmitted almost 16,000 images of Mars over the course of about 700 orbits. And then the Viking 1 lander took this incredible image, the first panoramic image taken from the surface of Mars. For the first time, we can see what it would be like to stand on the Martian surface. The landers also recorded information about the planet's climate and a precise cataloging of the Martian soil, made largely of iron-rich clay. Lastly, the landers conducted 3 experiments designed to uncover signs of life on the planet, but they did not uncover evidence for the presence of living microorganisms in the soil. After the Viking missions, the world took a break from Mars missions until 1988, when the Soviet Union launched the Phobos 1 and 2 space probes, named after one of Mars' 2 moons. Phobos 1 failed, and Phobos 2 managed to transmit 37 images of the moon Phobos. These would be the last Mars missions attempted by the Soviet Union, putting its mission total to 20 over the span of 28 years, which speaks to their commitment, if nothing else. Can we get a golf clap for perseverance? Anyway, NASA came back on the scene in 1992 when they launched the Mars Observer Orbiter that lost communications, ending its streak of 5 successful missions in a row. Skipping on to 1996, a busy year for Mars exploration. In November, NASA launched the Mars Global Surveyor Orbiter that would go on to make discoveries for the next 10 years. The MGS was a global mapping mission that revealed evidence of ancient lava flows, and it uncovered a multitude of gullies formed by flowing water. Some of the gullies suggest that water may have been flowing on the planet as recent as 2001. That same month, the Russian space agency Roscosmos launched the Mars 96 probe that failed to leave Earth's orbit. Then, in December 1996, NASA launched the Pathfinder lander along with the Sojourner rover. Pathfinder was able to transmit over 16,000 images and over 8 million measurements of Mars' atmospheric pressure, temperature, and wind speed. The Sojourner was the first wheeled vehicle to be used on another planet and serves as a foundation for all future Mars rovers. The vehicle gathered data from the surface terrain and transmitted over 2.3 billion pieces of data, along with over 17,000 images. The rest of the 1990s was lackluster to say the least, starting with Japan's first and only mission to Mars with the Nozomi orbiter launched in 1998, which ran out of fuel before reaching the planet. The incident sparked the founding of AAA's 24-hour Interplanetary Assistance Program. Okay, I made that up. Anyway, NASA launched the Mars Climate Orbiter in 1998, then they launched the Mars Polar Lander and Deep Space 2 probe in 1999. All 3 missions failed. But NASA turned the corner in 2001 with the Mars Odyssey Orbiter, which is still operational to this day, making it the longest servicing spacecraft at Mars. The Odyssey revealed vast amounts of water ice in the polar regions buried beneath the surface. It also recorded the radiation environment, uncovering the risk to future human explorers. 2 years later, in the summer of 2003, the European Union's ESA launched the Mars Express Orbiter and Beagle 2 lander, the first planetary mission attempted by the agency. Mars Express remains a highly successful mission and is still in operation. The orbiter made many discoveries, including uncovering evidence of Mars having long periods of flowing water, along with recording mineralogy maps that are used to help plot the history of the planet. The Beagle 2, on the other hand, lost communications after landing. Also in the summer of 2003, NASA launched the twin rovers Spirit and Opportunity, arguably the most successful planetary missions ever launched. The missions were designed to only last 3 months, but the incredible Spirit and Opportunity remained operational for 6 years and almost 15 years, respectively. The rovers transmitted well over 200,000 images combined. They uncovered evidence that Mars once held habitable environments containing water, warm temperatures, and thicker atmosphere compared to today. Now we move on to 2005 with NASA's Mars Reconnaissance Orbiter. The spacecraft made some great discoveries, such as measuring the volume of water on Mars' ice caps to be around 821 cubic kilometers, equal to roughly 3% of Antarctica's ice sheet. Then in 2007, NASA launched the Phoenix lander, becoming the first successful landing on a Martian polar region. The lander examined deposits of underground water ice first detected by Odyssey. It observed falling snow on the planet, and it discovered perchlorate, a chemical on Earth that is food for some microbes. Moving along, 2011 had 3 Mars missions. On November 8th, Russia launched the Phobos Grunt orbiter, and China launched its first mission to Mars with the Yinghao 1 orbiter. Both failed. And the third mission in 2011 was NASA's Curiosity rover, which was the first rover to drill into a rock and collect samples from another world. The rover detected sulfur, oxygen, nitrogen, carbon, among other life-forming chemical ingredients. It also measured radiation levels on the surface, which suggests that they are in a comparable range to what astronauts experience on board the ISS. 2013 had 2 missions, including ISRO's Mars Orbital Mission, India's first planetary mission. The mission is primarily a technology demonstrator, however, it is currently studying Mars' atmosphere and mineralogy. The second mission, launched in 2013, was NASA's MAVEN orbiter, with the goal to determine how Mars' atmosphere and water were lost over time. The orbiter revealed that solar wind is responsible for stripping away the atmosphere of Mars over the years, leading to the evaporation of the planet's water being dispersed into space. 2016 brought the EXO program, a joint mission between ESA and Russia's Roscosmos. The program consists of the Trey Gra orbiter and the Schiaparelli EDM lander, launched on March 14th. The orbiter is designed to learn more about Mars' atmosphere, and its research and findings are still unfolding. However, the lander lost communications during the final landing stages and failed. Finally, the most recent Mars mission was launched in May 2018 with NASA's InSight lander that touched down on Mars' surface back in November. The lander is designed to study the interior of the planets, where scientists hope to obtain a further understanding of how the solar system's planets formed and how they evolved. The InSight is the latest iteration of mankind's deep curiosity for Mars. From ancient times, when all we knew was a reddish speck of light wandering the night sky, worshipped as a deity, to the late 19th century, where the planet appeared to contain a vast network of irrigation canals, leading to wild speculation of intelligent life on the planet. While Mars has been demystified over the years, it remains the most studied planet besides Earth by far. Over the past 58 years, humanity launched 54 missions to Mars. The fact that only 26 of the missions were successful illustrates our resolve. And there are many more missions to explore Mars planned for the next 6 years, involving many nations including the EU, India, Japan, China, and the United Arab Emirates. And with SpaceX Starship and Super Heavy rockets development in progress, we will witness humans walk on the planet in our lifetime. Mars exploration has only just begun. Alright, that's all I have for now. I hope you enjoyed your journey. If you did, please leave a like and subscribe. I am NeoScribe, and I'll see you on the next journey.